Hello there, LearningHub family. Ever wondered about those medical test results? You get a positive and your heart sinks. But what's the real probability you have the disease? Today, we're diving into a powerful concept that helps us answer exactly that. And the topic is Bayes Theorem. Now, don't let the name intimidate you. At its core, Bayes Theorem is a fundamental result in probability theory that allows us to update our beliefs about the probability of an event based on a new evidence. Think of it as a logical way to refine your initial guess with fresh information. The formula itself looks like this. P of A given B equals P of B given A multiplied by P of A and all divided by P of B. Let's break down this formula, which might look a bit complex at first, but trust me, it's super intuitive once you understand its parts. So P of A given B is your posterior probability. The probability of event happening given that event B has occurred. This is what we want to find. P of B given A is the likelihood, the probability of observing event B given that A is true. And P of A is your prior probability or your initial belief about A before seeing any new evidence. And P of B is the evidence, the total probability of observing B across all outcomes. Alright, the theory is great, but let's make this real with an example. Imagine a rare disease that affects one out of every 1,000 people. So the possibility of someone having this disease, our prior probability, which we can write as P of disease, is 0.001. Pretty rare, right? Now a doctor uses a medical test. This test is pretty good but not perfect. It's 99% accurate if the person does have the disease. This is what we call as the true positive rate or our likelihood. We can write this as P of positive test given disease, which equals 0.99. It's 95% accurate if the person does not have the disease. This is the true negative rate. This means that there's a 5% chance of a false positive if you don't have the disease. So P of positive test given no disease is 1 minus 0.95, which equals 0.05. Here's the crunch question for you. You take the test and it comes back positive. So now what is the probability that you actually have the disease? This is our posterior probability, which we're looking for as P of disease given positive test. To calculate this, we first need to figure out the evidence or the total probability of getting a positive test result, which is P of positive test. A positive test can happen in two ways. You have a disease and the test is positive, which is a true positive, and you don't have the disease and the test is still positive, which is a false positive. So P of positive test equals P of positive test given disease multiplied by P of disease plus P of positive test given no disease multiplied by P of no disease. We know P of no disease is 1 minus P of disease, which is 1 minus 0.001, giving us 0.999. So let's plug in our numbers here. P of positive test equals 0.99 multiplied by 0.001 plus 0.05 multiplied by 0.999. This works out to be 0.00099 plus 0.04995, which gives us a total P of positive test of 0.05094. Now that we have all the pieces to apply Bayes theorem, our formula is P of disease given positive test equals to P of positive test given disease multiplied by P of disease all divided by P of positive test. Let's plug in our numbers. P of disease given positive test equals 0.99 multiplied by 0.001 all divided by 0.05094. This simplifies to 0.00099 divided by 0.05094, which is approximately 0.0194. And there it is. The probability that you actually have the disease, even after getting a positive test result from a 99% accurate test, is only about 0.0194 or roughly 1.94%. Mind-blowing, right? This is the power of Bayes theorem. Our initial belief was that the disease was very rare. Even with a seemingly accurate test, the high rate of false positives in the general population where the disease isn't present significantly impacts the true probability for an individual. It highlights that the accuracy of a test alone isn't enough. We need to consider the prevalence of the condition in the population. So next time you encounter statistics, especially medical ones, remember Bayes theorem. It's a critical tool for clear thinking and making informed decisions in a world full of probabilities. Alright, so if you found this video helpful, smash that like button, subscribe to Learning Hub for more insightful content, and let us know in the comments what other complex topics you'd like us to demystify. Thanks for watching and keep learning.